Okay, so it turns out my computer turned off for a second, so picking up where the last video left off, we found our critical points. Now, just to figure out what the maximum volume will be, we just need to plug it into our formula for the volume. So it turns out that it is a little bit easier to plug in values when V is in a factored form. So that would be what we started off with here. And in fact, we can just combine these two 10 minus 2x's into 10 minus 2x squared times x, and this will be just a little bit easier to work with than this full multiplied out form, at least as far as plugging values in goes. So we will use that. Now, to find the absolute max, we are using the endpoints of the interval, so that will be 0 and 5, and then also our critical points. Right, so we have 0 and 5 in our critical points. 5 is one of our critical points, so we are obviously going to evaluate at that as well. So we just need to evaluate v of 0, v of 5/3, which you should verify for yourself that this does lie in the interval 0 to 5. So remember, if a critical point lies outside of that interval, we ignore it. But in this case, it does lie between 0 and 5. So we will evaluate v there and then also at 5. Okay, now looking at our formula for v, we plug in 0 and it should be somewhat clear that we get 0 in that case. Next, we want to evaluate v at 5/3, so plugging in, we will get 10 minus 2 times 5/3 quantity squared, and then multiply by another 5/3. And so we can simplify this. This will give us 10 minus 10 over 3 squared times 5/3, and we will so we can find a common denominator here. That would be 3. So we would get 30 minus 10 over 3 squared times 5/3. And so that will be 20 over 3, giving us 20 squared times 5 over 3 cubed, which is 27. So if we multiply this out, we would get, let's see, 400 times 5, which would actually give us 2,000 over 27. So that is going to be v evaluated at 5/3, and that is actually going to be the max because when we plug in 5, so we should maybe already expect this from the argument we gave earlier about the domain, but when we plug in 5, we do get 0. So if we go ahead and do that, see that we get 10 minus 10, so we get 0 times 5, which is just equal to 0. So our max volume is going to be 2,000 over 27, and let's write that down. 2,000 over 27. Remember, the side length was measured in inches, so the volume is going to be in inches cubed. In fact, I'll write this like this so it's a bit more clear. 2,000 over 27 inches cubed. And the question does ask for how large the square cutouts should be. So we'll give the x value as well. So max volume is this, and the square cutouts, or we'll say which occurs, just fix this, occurs when x is equal to 5/3, or the cutouts have side length 5/3 inches. Right? So that is going to be our answer. So max volume occurs when x equals 5/3 or the cutouts have side length 5/3 inches. Okay, so that is going to be the answer for this problem, and we will end here, and don't forget to complete the comprehension check question.